Okay, as we look at example 5 on section 4.7, it says it wants us to find the area of the region bounded by the graph of f of x equals, and then it says we have 1 all over the square root of 3x minus x squared. And we're going to bind it between x equals 3/2 and x equals 9/4. So again, you're going to notice the power of this denominator is 2, and the power of the numerator is 0. So since the power of the numerator is 2 less than the power of the denominator, you're looking at one of the arc patterns. And since there's a square root, we're either looking at probably an arc secant or an arc sine. So as we do this problem, it looks like we're going to have to manipulate this one by also completing the square on it. And when we complete the square on this one, we got to be a little bit careful because it is written as with a negative in front of my x squared. So here's my integral that I'm setting up. So I've got this integral here. I'm going to go from 9/4 and 3/2. And then I've got dx. This is all over the square root of 3x minus x squared. So I'm going to work with this denominator here, and I'm just going to rewrite this denominator with this negative x squared plus 3x. I'm putting it in descending order, and then I'm going to put this in parentheses right here. And you're going to notice that when I do put it in parentheses, that's going to change the sign right here from a positive to negative. So that's going to come out to be x squared minus 3x. Okay, now remember, as you complete the square, you're going to take half of that b term, which in this case is negative 3, and you're going to square that. So half of negative 3 is negative 3/2, and then negative 3/2 squared is going to be a positive 9/4. So that's going to be my number that I'm going to be using inside of my integral. So I'm just going to rewrite it over here so it looks a little bit better. So I've got my integral from 3/2, and then I'm going up to 9/4. And I've still got my dx in my numerator. And I'm just going to rewrite this as the square root of. And so you're going to notice I've got my negative, and then in parentheses I've got my x squared minus 3x, and then I've got plus 9/4, which makes that a perfect square, because remember that is half of negative 3 squared is your positive 9/4. Now when I do put this out front, I'm going to have to offset it, but you're going to notice that it is negative when I distribute it through that set of parentheses there. So I'm going to need a positive 9/4 right here out front, so that when I take a 9/4 minus 9/4, that is going to be equal to 0. So now I've got my integral, and it's going to be from 9/4 to 3/2, and I've got dx, and that's going to be all over. I'm just going to go ahead and rewrite this as the square root of 9/4 minus, and I'm going to factor that. So x squared minus 3x plus 9/4 factors to x, and it's going to factor to, let me get rid of this right here, it's going to factor to x minus 3/2 squared. So now that I've done that, I've set it up so that it fits the arc sine pattern, because it is a constant minus an equation squared. So I'm going to let my a squared equal 9/4. So that means that a is going to equal 3/2. And then I'm going to let my u squared equal x minus 3/2 squared. That means that u, when I take the square root of both sides, is just going to be x minus 3/2. So du is going to equal dx. So since du equals dx, there is nothing that is missing from my equation. Now that I've done that, I'll just scroll down just a little bit right here. I remember my arc sine pattern. So you remember the integral of du all of the square root of a squared minus u squared is equal to my arc sine of u all over a plus c. In this case, of course, we are at a definite integral, so I won't be putting in my c, but it does fit the pattern, so this is going to equal the arc sine. And my u in this case was x minus 3/2, and that is all over 3/2. And then I'm going to evaluate that from 9/4 to 3/2. So now to evaluate this from 9/4 to 3/2, it's just a matter of substitution. So I've got my arc sine. So remember that's going to be f of 9/4 minus f of 3/2. That gives me my arc sine of 9/4. I substitute that in for my x value, minus 3/2 all over 3/2. Subtract f of 3/2, which would be the arc sine of 3/2 minus 3/2 all over 3/2. So when I simplify this down, that's going to give me the arc sine, and 9/4 minus 3/2, well, 9/4 is, or 3/2 is 6/4, 9/4 minus 6/4 is going to be, or 9/4 minus 6/4 is 3/4, so that's going to flip and multiply, so that's going to be the arc sine of 1/2 minus, and then the arc sine of 0. Well, the arc sine of 1/2 is going to be pi over 6 minus the arc sine of 0, which is 0. So my answer is pi over 6. Or if you put it in your calculator, you'll get a decimal answer of 0.524.